practicum, like a walkthrough. We're going to take an object-oriented program and turn it into a functional implementation of the same code. In doing so, we're just going to talk through the patterns of refactoring object-oriented to functional. The whys and the theory and all of that are fantastic, and there's tons of great talks about that, and I'll be giving a talk about that on Thursday. But for today, well, we will conversationally delve into those things. I'm not going to formally, like, intentionally try and talk about each of the specific, the philosophy and the whys. I do want this to be conversational. I'm not planning on live demoing to a quiet audience. I would love to have people asking questions, challenging my assumptions, talking about other approaches. I'm not going to claim that this is the right way. Like so many things in programming, there's always more than one way to do it. I'm not even going to contend that it's the most Pythonic way, because some of the things I'm going to do, especially at the very end when we start just, having fun, are going to definitely make the code less readable. I just want to show, like, the paradigm, because some of these things apply more in other languages than Python, and show how to get a Pythonic or a generally Pythonic functional approach to what is currently an object-oriented module. So let me just talk through the module that we have real quick here. Some of you, just from the names, can probably already kind of figure out what this does. I have a bunch of CSV files, CSV, tard, zipped, PSV, so pipe separated, right? I just have a bunch of files. The contents of the file are not interesting. You can see that it's a letter, it's integer value, it's hex value, and it's octal value. Like, we really don't care about the data. This is more about the processing of a file. You can also see that I've got, like, blank lines in my files and stuff like that. Like, this is just, random data to look at. But what we have is we have a program that basically unpacks that file for us and delivers it as a set of rows, where each row is the output of a CSV reader, which basically means it's a tuple. I'm sorry, a list. So it'll be a list of strings. And we're going to, so we give the file name in the constructor, and it does some setup, it does some stuff. And when we tell it to iterate over the file, it gives us the rows back as rows, right? Nothing fancy here. Hopefully the program itself is simple enough you can kind of look at it and see what's going on. Even if you don't understand every method, just the basic structure should be familiar. We also have one conditional in here. We have this idea of a decompressor. If the file is zipped, it will unzip it first. And so I've got a class that does that, right? This is an overly simplified example. If you look at this code, you'll say, well, I would never write it exactly like that. Well, it's designed to include a few things that make it more complicated than it should be for this specific problem. But again, it's to convey concepts more than But I mean, if you look at this, you should be familiar. Like, this should look like stuff you've written before. Maybe not your best code, but the patterns here should be kind of familiar if you've been doing object-oriented for any length of time. So I just want to show the program running and kind of see, what the output looks like, and we'll walk through one quick walkthrough of the program in action, and then we'll start talking about refactoring it. So to run it, I just give it a file name. So we'll give it the CSV file. Whoops, why did nothing get printed out? That's a surprise. Okay, I have terminal issues. If I have hang on just a second. Oh, I ran the wrong program. There we go. Okay, so I've got this simple wrapper around it. I forgot I had this here. I've been running it out of this file directly for so long, I forgot I'd split it out. All this does is you call the program, you give it a file name, it instantiates our object, it calls a couple helper methods on it just to give us some information about the object, and then it iterates the object and prints out the output, right? Nothing fancy. And we can see that if we give it a CSV file, it prints out the file name, all the extensions it found on that file, and then the contents of the file as one list per line of input, right? Again, nothing fancy here. But what we want to do is we want to functionalize this. And I do want to talk just a little bit about why. Like, why would you take this program that works and think about refactoring it? And there's a lot of great arguments for this, but in a nutshell, it comes down to maintainability and testability. Object-oriented programming has been a great model for conceptually understanding software when you have a lot of very complicated pieces interacting together. But it has led to some paradigms where a lot of people are starting to look now and say, well, wait a minute, it's actually adding extra layers of engineering in places where that might not necessarily be appropriate. So the motivation is to think about, how do we make our code more testable, more grokkable, like so I can just look at it and have a better understanding of what it's doing. How do we make it easier for a new member on the team to understand it? And can we gain anything from that? So there's a few refactorings that we can look at to get there. Well, and actually, if anyone is brand new to functional, if you don't know what it is, I'm happy to dive on that, but I'm assuming everybody has like some notion about the whys and what it is. Essentially, functional programming is the removal of state and side effects from your code. That's a very big ambiguous statement, and there's it's a deep dive in and of itself, but really it's about finding places where your code has dependencies on other code or state that it impacts, that changes the behavior of other code later, finding those and removing them. And what you get from that, like I say, is more maintainable code. So with that background,
can you give one side effect or one state that's existing in the current OO?
Sure. So when you instantiate your object here, it is actually storing off things like the file name, the extensions. It's even setting up state around how to do decompression at instantiation. Then later, when you execute that object, all of that state is influential in how the object executes.
Wonderful. And are there any side effects of this code as it is?
This one currently has no side effects external to itself.
Got it.
It's a little overly simplistic in that regard, but the patterns we use will cover the same scenarios that, like if it had side effects that influenced anyone else, these patterns will identify those situations as well. So there's a few things we want to do. One is we want to purify functions. That is, take any function that has state and remove the state from it. Take any function that that causes side effects and remove those side effects from it. And another thing we want to do kind of right from the start is just think about how state works in our application in the first place and where we can eliminate it altogether. So the first refactoring is one that I call Purify Function, or you could think of it as extract method to module if you're used to the Fowler naming convention for refactorings. So we have this method that is a method on our object. You'll notice that it has self. It has to, because it's a method on our object. Well, it doesn't have to. There are exceptions to that, but it's it's an instance method. So it has self and it has content. But you notice that nothing in this method depends on self. So this method by itself has no state other than the data that's passed to it. That's the only data it has to work with. So this is really easy. This refactoring is, we want to make this a module method. So we're going to move it out to the module level. We don't have self, so we take that off and we find any references to this and we remove self. All I've done, whoops, oh, sorry. I have too many warnings turned on. I did my run through on my other laptop yesterday, and I forgot to do a final run through on this one. Okay, so all I've done is basically I've taken a method that was a class method and moved it out to the module level. Nothing about my code is different other than that. And if I rerun this, I should see that it works fine, right? But what I've gotten from this now is this method, at least, not the others, but this method, I can call it from within my main class here, but I could also call it from anywhere else. Like this is just a wrapper around take a block of text and turn it into CSV rows, or turn it into rows based on the CSV parser. So now it's sort of a general purpose utility method rather than a method that's specific to my class. So that's handy. Similarly up here, this unzipper, right? We have this notion of decompression, but the decompression it does really is actually stateless. It is given a block of content and it does some decompression on it. It opens up the zip file. It goes and finds the name of the first file in the zip. It opens that file and it returns the contents, right? This is all this depends on is the block of content, the block of data that's passed to it. So this one too, we can move out. Now, of course, this is gonna be a little tougher because we have a helper method here that I'm gonna put back in just for a second. Return. That out, and now we've refactored this method out to the top level too. And again, the motivation here is just to make things, to get things out of classes when they aren't necessarily part of that class. I'm going to just do a couple quick renamings here. I'm using the underscore rename to mean that anybody outside this module should not be calling or looking at this thing. This makes the method, I mean, Python doesn't enforce that. Anybody can call it if they want to, which means it's fully testable. I can test these methods independently, but this is a signal to people that you're not supposed to call this method. It's here for my code to do its thing. So I'm going to be using that convention. I'm also going to name my functions fairly overly obviously, just to track the process as we refactor. Later, I would probably go in and give things better names. But if a function takes text and outputs rows, I'm going to call it text to rows. So this one takes in bytes, zip, and outputs bytes. Okay, simple enough. However, that means I need to rename this. Okay, so I've got my helper class now calling a top level module method to do its part of the job. So let's run this again. On a regular CSV, it works. If we do it on a zip, I didn't show a zip working, but it basically is the same output. It unzips it, right? So that refactoring hasn't changed anything. Boy, this is going to drive me nuts if these things keep popping up.
While you're fixing your lunches, I got a question.
Sure.
So the renaming you just did there, I think, does make it a lot more clear with that function. The first one, text to rows, something my students ask me a lot. When you move a function outside of a class because it doesn't use self. Why do that as opposed to making, say, a static method like you would in maybe Java? Well, I mean, in Java, you have to make a static
right,
method.
In Java, you have to. You're tied to objects in Java. In Python, I would say you would do this instead of that because you can. So a static method is useful. The mental model of a static method is I have this method that is only meaningful in the context of my class, but it can't be called in an instance of a class. So it might be a factory method, or it might be a, some kind of helper that's related. If your class is the thing that you're delivering and people need to be able to access all the behaviors on it, static methods on a class can make a lot of sense. But if you remove the objects entirely and instead of exporting a class, you export a module and it just has all the helpers it needs, then there's no extra value in having it as a static method. The value is in the mental model of what the software does, more than in the actual performance. In fact, there's a very, very tiny performance hit for having a static method over a module method, but such a minor hit as to be inconsequential. But it's more about the mental model of what the software is doing, and our goal at the end of this is to not have classes at all. And so knowing that with that in mind, we're going to jump past the static method and just go to module level methods. Does that?
Yeah, I think that answers the question. Although one
okay.
thing that's kind of interesting with this example is you put the underscore before it to note that it's not meant to be used by anyone outside the module. And putting it inside the class is kind of a level of hiding that doesn't make that more or less relevant. If this was something that was meant to be a helper function, I could see an even stronger argument for moving it outside of the class, say.
Mm-hmm. Yeah, I mean, it really depends on context. I happen to know that at the end of this, we're not going to have any classes. So I'm just sort of bypassing that step. But there's definitely a valid argument to be made in both directions on that. And I think it would really depend on the project and the circumstances.
Awesome, thanks.
You're welcome. So far what I've done is I basically just took my any methods that didn't depend on any state, that only depended on their parameters, and extracted them out to the module level. At this point, there are no methods left for which I could do that. But I do want to at least get rid of this class because it doesn't really serve a purpose anymore. We're setting up this decompressor, but we could actually just have this point to the method. Byte zip to bytes, if self extensions is zip, else none. And then down here, instead of calling decompressor compress, we just call decompressor. That should now, boy, how do I make that warning go away? Every time I save, that's going to pop up. It's going to drive me nuts. I have my other environment set up perfectly, and unfortunately, that laptop's not available to me right now. Okay, so now by making sure that when I do my initialization, I just point to the method directly rather than pointing to the helper class, this class is now meaningless. So I've gotten rid of one class already. Whether or not that's a good thing, if I just did this refactoring and delivered this code as a pull request, that probably would not be the right choice, right? It's built around this objects model. We should keep it in the objects model. But the overall refactoring, this is just step one. So it makes sense to start getting rid of classes when we can. Okay, so the next thing I want to look at are methods that have state, but that the state is relatively easy to extract from it. And iter is a great example. What this method does, I'm assuming everyone here is familiar with dunder iter, but just in case you're not, the basic idea is if I have an instance of this class and I iterate over it, for example, this line right here causes this to iterate. And so if I have an instance of the class and I iterate over it, it then goes and opens a file, reads in the contents, decompresses them if they need to, then decodes it from bytes to text, and then converts that to rows. So in all of these steps, I do have some references to self, right? The other methods when we wanted to pull them out did not, this one does. However, the things it's pointing to could legitimately be parameters to the method. So here's what I'm going to do. I'm going to first move this out to the top level and remove self. That way the editor will start telling me where I have problems, except of course my linter is not hooked up properly for reasons that baffle me. So I'm not going to see those that help. I'm going to rename this now, and I'm going to call this the same thing as my class was called, because really this is the replacement for the file to rows object. So the intent is this takes in some data, probably a file name, because it does need that. Probably extensions, it does need that. And so now we can have this refer to the file name directly. Oh, a decompressor. And we may not even save in a state where these things are done this way, but for the moment, we're just going to pass everything in. So it has no references to self. If we were to call this like this, pass it a file name, extensions, and decompressor. Actually, it doesn't need extensions. That was already handled elsewhere. Okay. Give it the file name and decompressor. In theory, that should work. You know what? I'm going to put that iter method back and just have it call that. Return file to rows of self dot file name self dot. In theory now, other than having to ignore warnings, in theory, this program should still do the same thing. It does. So all I'm doing is calling this top level method and passing in the name of the file and the decompressor to use. Okay. However, now that I'm doing that, well, I really could call this method directly. And the only logic that I don't yet have in this method is this notion of deciding whether decompression is necessary. So I could just move this logic into there, and we'll do that in just a second. But as I look at this method, or at this class, the only thing in here now at this point is dunder iter, which we're going to get just by calling this method directly, so we don't need dunder iter anymore. It has a wrapper around the iterator. It has an extensions and file name calls that help me understand what the state of the object is. But if I'm going to get rid of objects, I don't need state of the object. So those are kind of useless. Really, all that's left that I care about is this right here. And the only reason I care about any of it is this line. So at this point, I can really kind of get rid of this class. So I'm just going to collapse these for a moment and start thinking about how I could move this into the other method. And really to do that, there's two things here. I need to figure out what the extensions are on the file, and then I need to do something with those. So that means I probably need a helper method for extensions to do this logic, or well, maybe a helper method. I'm going to go ahead and do it as a helper method because why not? Later, I can decide that it's overly decomposed and put it back. So this is going to be extensions from file name. And again, these names are not meant to be the final names as much as they are just so we can glance at them and know exactly what it does. Right. If I were doing this for a team that already knew the nomenclature for our domain, I probably would go straight to the names that we would use. But for this, I just want to keep it simple. So what does that do? It returns file name dot split on dots, not the first one. Right. So now I can get the extensions given a file name, which means this doesn't have to know anything about extensions. It only has to know the file name. I can just call that extensions equals extension file name, right? Nothing fancy here. This is all just really simple stuff, which means I don't need this part of the code anymore. And then this, I can just set the decompressor down here in the same way. Where to go? Decompressor equals that. Now I don't need to pass this. Now if I just call this method with a file name, in theory it'll work. So let's take that away and see if calling through the class, it still behaves right. Doesn't behave right because I didn't remove that. There we go. Okay, so my code still works. And at this point, this is a magical moment because at this point, the class no longer serves any purpose whatsoever. The whole class can go. And all that will happen is my wrapper code will fail to work because it's still expecting the class to be there. So we'll just call this differently. This is now file to rows in smalls. The output of this is the iteration. So we're going to move that to here. And so now at this point, I've changed my API. Any user of my module has to change their code. I still want to omit the file name, but I'm just going to omit the actual file name I got. There's no reason to run it through a class to get there. And with the extensions, well, I can call that method directly. So just for sanity checking while I'm testing my code, I'm going to go ahead and call that method. So this would be parse csv dot extensions from file name. We'll get the file name. So now, right now, what I can see when I run this is it's still using the same file name. It still sees the same extensions, and it still decodes the file. So I have completely eliminated objects. Now, by itself, that's only a secondary goal. That's not the primary reason we're doing this. This isn't in an ideal state at all. But the basic idea of taking your objects and decomposing them into functions, you can see is a fairly straightforward process. We're really just looking for cases where an object is holding state and thinking, what if I were to pass the data it needs at the time it's called, rather than passing self and having it extract state from self. So I'm removing the assumption that there's an object altogether and just passing parameters directly for the things I need to do. And most of these methods, the only parameter they need is the file name. Well, not most. The external facing method just needs a file name. All of the internal facing methods need either the file name or just some block of content. There's not a whole lot of weird wonky logic going on here. So far, any questions on what I've done so far? Like, this is the easy stuff and the low hanging fruit, but it's also the easiest to go look at any code that you've never worked with and just jump in and do these kinds of refactorings fairly easily. So
I have a question about the file name split.
Sure.
It's rare, but if a file name has lots of dots in it already, wouldn't you want to use a negative to start from the right and get just the very far right extension?
That's a great question, and I'm going to answer it this way. For our program, we're going to assume that the first part of the name doesn't have dots in it, okay, and that every extension is an extension we're interested in. So for example, if we have a CSV zip, that really means it's a CSV file wrapped in a zip file. If we have CSV TGZ, right? So we're assuming that all the extensions matter and we have to do something for every extension.
Okay. Sort of a follow-up question. None of these CSV files have a first row that's the table headers or the column headers, right?
Yeah, the nuances of parsing CSV and all of that, I'm kind of pushing to the side to focus more on the process, but you're right. Those are all questions you would have to ask. Handling header rows, all these things. These are additional logic you would have to build in if you have to account for variations in those cases. Okay. And if every CSV file always has a header row, obviously you just encode that in your call to CSV reader, right? You don't even really worry about it, but that's going to be very much problem specific.
I have maybe a semantic question.
Sure.
So what we've done so far, I have done on my own code, client projects, all sorts of stuff before. You've got classes and you realize, I don't really need this class. Let's make it functions. I don't think of this in my own mind as functional programming per se, as much as maybe functional-ish programming, that there's functions and there's functions calling functions. But I don't think in terms of, is this functional? And that part of the reason is that word functional kind of is loaded in my mind in terms of
Mhm.
different paradigms and programming languages have different opinions. I'm curious what would make this not functional, despite the fact that
Sure.
it's purely functions.
A few things. One thing that's not functional, even though this is a function, the function itself is imperative. That is to say, it's a list of statements and assignments. Pure functional programming has, boy, I'm going to step on a landmine here. Pure functional programming has no assignments except the assignment of constants at boot time, at application start. Every variable is constant. And that has a whole lot of people reeling, I'm sure. The reality is, if you're writing in Python, you're not going to be pure functional. It's very rare you'll see something in Python that's even close to pure functional, but you wouldn't want to be pure functional because the Python language is not built with that in mind. You would
Right.
actually get better performance by not going all the way. However, so that's one thing. The fact that we have imperative code rather than declarative code makes this not functional by definition. And actually, we're going to address a lot of that in the next set of refactorings. The first one was just sort of like moving to a functions-based view of how the code works, of how the module works. Now we're going to start really extracting the real meat of how do we get rid of a lot of the complexity of imperative code. Complexity is, I don't know, I'm not sure the right word for that. I'm gonna think about this for a while. But we want to get rid of as much imperative code as we can. Things like, so this is semantics. This is a expression, right? An expression has a value. And this is a statement where one kind of statement is take an expression and assign the value of that expression to a variable, right? So if we only had this, this line would not be imperative, but because we have assignment, it is. So that's like your litmus test. If you look and you see a lot of assignment, if you see logic statements around like branching and looping and stuff like that, you might be functional, but as soon as you see those kinds of things, you're probably not purely functional. But you're right. It is a, what functional really is a giant thing, and so we're gonna approach that. We're gonna approximate it. We're not going for 100%.
Right. I think probably I'll ask the next follow-up later because it might be a little bit of a distraction now, but it kind of seems to me like this process that you just did might often result in almost functional code frequently in Python, but I'm sure that there's probably some exceptions where there's some side effect that, besides the imperative declarative, besides maintaining state and local variables, that makes this could make it not functional. But you had said at the beginning that this didn't really have side effects anyway.
Yeah, I think in this case, there probably is nothing except, I mean, there's the implicit side effects like RAM usage and things like that. Like if I read a big enough file in, this is going to have side effects to the rest of my application just because I'll exhaust the RAM, right? I'm reading the whole file into memory, decompressing it in memory, like, so parts of this can have impact on my program as a whole. But in terms of like just looking at the code and following the logic, in theory, there are no side effects. In practice, of course, who knows what anybody else has done in their module that might cause side effects, for example.
Cool. I'll ask more later.
Sure. Oh, please do. Okay, so now we have this basic idea of we're given a file name, we figure out if we need to decompress it, we open the file, we read it, decompress if necessary, and then decode it, blah, blah, blah. If you look, the next thing I want to do is I want to start looking for places where I can actually decompose this, because it's not a hard method. Like, I mean, if you were brand new to this code and you just looked at it, you should be able to figure out in not too long what's going on here. However, it is doing a few things. In pure functional programming, one of the goals that you're aiming for, and again, these are soft targets. If you hit them exactly every time, you're probably not doing it right in Python. So these are soft targets. But one of the things you're looking for is every function should do exactly one thing, right? We all know sole responsibility, the principles around everything does one thing and does it well. And this function is doing a few things. So if we look at this, I can kind of just see at a glance that this still needs to be decomposed. This one maybe, although arguably this is in a pretty minimal form. The only thing I could do here is I could obfuscate the code just slightly to remove that line. And if I really wanted to go all the way, I could do that one, right? I don't think this is more readable. I think it's actually less readable, but I do actually like it in this state. This is a pretty dense expression of how to take a block of bytes and unzip them in RAM. I think it's fairly readable. Depending on the team, you might decompose it a little more, a little bit less, but I like this method the way it is. This method looks like it's doing one thing, but it's actually doing three. So we want to readdress that one. This method is doing one thing, doing it well. I'm pleased with that. This method is doing a lot of organizing. Really, all it's doing is iterating the content, but it's loading a file and it's running it through a whole bunch of stages of processing. And so this has a few things going on too. So I want to try and decompose those. I'm going to leave this one the way it is for the rest of the talk. Here again, the only things we could do to this function really are about readability, and I think it's probably in a good state the way it is for our purposes. And so I'm going to start focusing on this method. What I really see here are a few different things going on. One is setup. One is reading the file. One is basically this sort of sequences of steps where each step takes the previous output and takes that as its input and does the next step. So this is you can think of this basically as a processing pipeline. We have a whole bunch of function calls. The output of each one is the input to the next one. So it's just call this one, then pass it on to this one, then pass it on to this one, and so on. And there's patterns for that. So I'm going to actually, the first thing I'm going to do is I'm going to make this a little bit more lengthy to actually express exactly what all the calls are. So we have this call to decompress. Well, first of all, we have this call to read the file. I'm going to leave that like it is for the moment. Then we unzip the file if necessary. Then we convert from bytes to text. Then we do this text to rows, which I mentioned actually is doing several things at once. So let's at least make all of our calls follow the same pattern. Row in content. Okay, so now what we have is content equals, content equals, content equals, content equals, and the input to each function is the output from the previous function. Well, not this one, not quite. So let's make that true. So that was taking bytes to text. So we'll put a wrapper around it. Bytes to text. Boy, I can't type today. And that is just going to return this. And now this can be bytes to text. And now if we look at this, we see that it really is just function call, whoops, decompressor. Okay, so I'm assigning decompressor to this. I'm actually going to just put that right here. It will make sense as to, no, I'm not, never mind. I have a different way I'm going to do that. So I have one logical statement, but whether or not that happens, every stage of the pipeline, including that one, is just taking the output of the previous stage and calling the next stage with it. I do see one optimization here. If you're not familiar with yield, yield, I'm going to assume everyone has a general feeling for it. Yield just says, when I iterate over this, every time I ask for the next element, give me whatever the next item is. There's a shorthand for this pattern right here, which is yield from, boy, I cannot type to save my life today. There we go, yield from content. Which is the same as for item in content, yield item, right? And once more, I'm just going to double check. Whoops, boy, I'm going to have to solve that when I get off this call. It's going to drive me nuts. Yep, my program still is doing the right thing. Okay, so now what I have really is a sequence of steps, and only one of them is conditional. So these steps right here are all going to be, actually, and this one also, are going to be called every time, one conditional step. But the structure of how they're called is interesting to me because each one takes one parameter, returns one value. So these to me feel like, again, back to what I was saying, it's a pipeline. These feel like stages in a pipeline. So I'd like to actually start thinking about what those stages are think about what the pipeline is. If I were going to implement this as a pipeline. So in this case, the pipeline is a set of functions in a predetermined order, and that order is chosen by the extensions to the file. If it's a CSV file, it decodes the CSV part. If there's also a zip, it unzips, right? So really what I'm looking for is some notion of iterating over the extensions of the file and deciding what functions to call as a result of that. And that would look something like Boy, I had it in my brain just a second ago. Got myself distracted by those damn dialogues. Okay, so what we want our pipeline to look like, what we want our pipeline to look like is basically a sequence of calls. So let's just hand code a pipeline for the case where it is not compressed. So if we wanted to do, I'm going to do this in all caps because this is just going to be a tuple that is hard coded into the app for the moment. This is going to be file to rows with no zip. And all that is, I'm going to define it as a bunch of functions. First we do bytes to text. Then we do text to rows. And then we do, I think that's it. Bytes to text, text to rows. There we go. That is our pipeline. We can then use basically this as something we loop over. There's a variety of ways to do this, and we'll talk about a couple different ways. But we can basically just loop over the stages of the pipeline. The next, this one still has the conditional, so we'll hold off on that for the moment. But we can just say for stage in file to rows content equals stage with the previous content. Right. I contend that this does the same thing. It's a little bit more obvious. It's just function call on a list of functions that at the moment is constant. And in theory, our program should still work. It still works. So with non-compressed text, it works. With if we pass it a zip file, it's going to fail. Why didn't it fail? Oh, because I still have my conditional. That's right. So now I want to get this conditional in there as well. This is the first time we really have to think about, like, how do we approach this? And the solution I've come up with, actually, I'd like to hear some ideas first before I present my solution. I'd like to hear, like, how would you get from having a pipeline that's constant to a pipeline that is not constant, that has some kind of variations in it, knowing that the pipeline, quote unquote pipeline, is really just some sort of iterable of functions. So any thoughts on
for this particular case or in general? Because in this case, since it's none, maybe you could rely on
that. True. Okay, that's a good point. Yep, and I'm in the general case, but also this specific case. I mean, ideally, we're looking for answers to this one, but if they're generalizable, that's awesome. Any other thoughts?
So I don't know if I can describe the full answer.
Sure.
But one thing I was thinking about that will be related to this if we do later refactorings is maybe you want to support other formats besides zip.
Yes. Right? And you can see that I probably do based on what you see on the side
there.
There
you go. So what you probably want is some like pre-process file, like pipeline step, right?
Okay.
Where you just, I haven't fully designed this out, but like you
just thinking of something like this
process file, and then maybe you can, like, you know, register different extensions somehow with like different actual like processor functions. And so it would just look up the extension, call the right processor function, and then return.
Yeah. I'm gonna suggest that, like, what you're talking about, maybe, if I understood you right, maybe what you're talking about is something like this, where you actually just have a whole bunch of pipelines predefined.
No, I was more thinking of like extensibility. Like I was thinking extensibility wise, you might want to like have some way to like register, like, here's the target
I see what you're saying.
processor, okay, here's the whatever processor, but have them all run through one like entry point. So it just looks up which processor it should use and then returns.
Okay. Yeah, I like that idea. And actually what we're going to do is going to be in the realm of that. The way that I decided to approach this is I decided if I can just build an iterable at runtime, look at the extensions and build the right iterable, that would be really handy. So I'm gonna construct a dictionary that will help me build that iterable. And this will be a little bit wonky at the first. Stages for extension. And I've had a lot more time to think about this, and even then I don't know that this is the best way. I'm not claiming it's the best. I'm just claiming that it makes a lot of sense to me, and it ends up being elegant once it's built. So for example, for stages for extension, if I have a CSV and I'm using the dict call notation because I just don't like putting quotes around everything when it's all text. But this is the same as building a dictionary on the fly, right? You should be familiar with this syntax. And if you're not, I can expound on it a little bit. So, and then if we have a zip extension, the stages for that, well, there's only one, but it's this one. Make that a tuple. So now what I have is, if I see CSV, I put these stages into the pipeline that I'm building. If I see zip, I put this stage in. We know that we have to go from the outside to the inside, so we need to look at our extensions in reverse order and just pull out the set of functions we need to handle that extension. So with that in mind, let's write a function that builds our pipeline, given a file name. And what's it going to do? Well, it's going to take the extensions. Let's pass the extensions to it for the moment. Let's keep it simple. Build the pipeline. So what we're going to say is for extension in extensions, empty list for extension in extensions, pipeline dot extend. These are tuples, so we need to make them lists. All of this is going to go away in a moment. Stages for extension for that extension. You know what, I'm going to actually do this a slightly different way. I'm just going to work with tuples directly. There. Pipeline equals a tuple, and then at the end we return pipeline. So all I'm saying here is work backwards, because right now we're doing it forwards, work backwards through the extensions. So start with zip and go look up what are the things I need to do to get from zip to its, like what's the transformation from zip to the unzipped state? And that happens to be a single function, and it's this one. And then it says, okay, now I see CSV. And so what are the functions I need to do there? That's these functions right here. So now I've basically built an iterable that is all of the functions that need to be called in the order they need to be called. And let's look at what that looks like if we're not going to call the function directly, but we are going to go look at the output of it. So parse, boy, I really cannot type today. Build pipeline, file name. Okay, I'm going to go ahead and just comment this out for the moment. We don't need to iterate the file. I'm just going to build the pipeline and see what we get. Pipeline, oh, it needs extensions. Let's go ahead and fix that right now. I'm just going to, where in this upper method, the only reason we need extensions is to do this determination, but we're getting rid of that anyway. So I'm just going to determine the extensions right here. This might not be the most Pythonic. You might want to have separate lines for this, right? Make it more imperative, whatever. But I contend that this method's a little bit weird, but not too bad. We're basically just iterating over the output of this function in reverse order and building up a pipeline. Okay. Again, the level of your team might influence how explicit you make that code. Don't need that anymore. Don't need that anymore. Okay, so it builds a pipeline that is going to be bytes to zip, or bytes of zip to bytes, and then bytes to text, and then text to rows. That sounds like what we want. And if we passed in a file that did not have the zip, we get just bytes to text, text to rows without that bytes zip to bytes. That looks like the right pipeline. So with one simple dictionary that maps to extensions, and like I said before, we're working with the assumption that all of our extensions are meaningful and we have to operate on all of them. So with that in mind, we're now doing the right thing. That means that we no longer need to worry about the decompressor. We just need to iterate over the extensions and apply the stages. So now this method really only has three things it's doing: load the file, pass it through the pipeline, yield results. This method is doing the heavy lifting about figuring out what the pipeline is. The rest of these methods are the execution methods. So just to, you know, for grins, let's make sure we haven't broken anything, because it's just like me to often, oops, I'm gonna leave that line in. That's kind of handy. Like me, it's common to break things when I think I'm making them better. Nope, that seems to work. Since view.zip. Okay, that still works. I wonder if it would work on a TSV. Any questions about this code so far? What I just did there, like that technique is, I'm not an expert in functional. I don't know if this technique is really clever or just very obvious, or even the best. It's just one that works really naturally for me to build a pipeline dynamically at runtime.
Is that pipeline builder, is that an example of a factory pattern?
Sort of, yeah. I mean, so here's where functional terminology gets very strange. In pure functional viewpoints of the world, in pure functional paradigms, what you're really looking at is everything is a function. And I do mean everything. Everything that's not a value is a function. Even many values are functions. So functions are first-class objects, or first-class members. It means you can pass functions into things. You can receive functions out of things as return values. Functions can kind of be used everywhere, and there's real power in that, but it also leads to some confusing nomenclature. So I don't know that factory is the right name for this in a functional world, but it serves the same purpose as a factory. And having functions that build up intermediate structures that are useful for other functions is a very common thing in functional programming. So factory is probably a good way to think of it, but I'm not positive that that's technically the right word.
I'm curious, that little content thing you've got, if you know, the reassignment to content equals in the for loop, because you noted that storing state, if you can avoid it, or, you know, rewriting a variable would be something you'd want to avoid in functional, in a pure functional context. Would recursion be something that someone would use in a case like this if they wanted to not be reassigning to content over and over? Is that kind of taking it a step too far?
That's actually a great question, and the answer is there's many ways you can handle that. The way that we're going to go is going to be a sort of a mind bender. We're going to turn this into a reduction. So if you're familiar with the map reduce paradigm, we're actually going to eventually get to a point where we just do a single reduce our list of stages and starting content to a final answer. So this whole thing will become one line of code. But until we get there, I think just for you're right to ask the question. It's a great question. But until we get there in this particular case, I think we'll probably leave it the way it is. But you're right. There's different ways to approach this. And another side note on functional programming, because purely functional languages are designed, like Python was designed around more of an object view of the world. You don't have to use objects in Python, but so much of the internals of Python are object-oriented. And if you read the Python source code, you'll find that a lot of it is built around the idea of objects and methods on those objects. Like everything's an object and everything has a stir method and everything has a, you know, Python views the world in object-oriented paradigms, even if your code isn't using objects. But in a purely functional world, it's very common to have, like I say, functions can take functions as parameters, functions can return functions. Functions also, boy, I had a thought I wanted to say and I lost it. We were asking about.
Maybe it was like partial application you were getting toward, because that's one thing I was kind of thinking of here is recursion in Python's kind of ugly compared to some languages.
Yeah, so recursion in a purely functional language has some amazing properties for validation and also some amazing performance enhancements in practice. So that if you're using a language that is purely functional, you will almost always write every function in terms of recursion. And in fact, I think the proper way is every function is always done as recursion. You never loop, you always recurse. And to those of you who are thinking of stack traces and what that looks like in that world, the reality is if your recursive function is written the right way, the compiler can actually turn it into a for loop, and at runtime it executes as a for loop, not as a recursive function call. That's not 100% true. Yes, tail recursion basically. If your code is tail recursable, then it recurses it and turns it into essentially a for or a while loop. Python doesn't do that. So in our case, trying to write things to be readily recursable is kind of a aiming in the wrong direction. But note that that's true, and in some languages, you actually would want to rewrite all of these as recursive.
Hey, Jeffrey.
Yes. Yeah.
At the start of all this editing, didn't you have something that was class something, and then all these defs were like a subset of those?
Yeah. So these were we've added some new functions that didn't exist at all. But when we first started, actually, let me just open the starting code. We started out with code that looked like this. So we had
class unzipper, class file.
Yeah. So that first step really was just getting all of the things inside the class, outside of the class. But now we're really thinking about why they're written the way they are, and looking at other ways to write them to you know, and so that's why we're having this next stage of the exercise. You're welcome.
Another question. I noticed, is file name a protected name in line 6?
It is not.
That's not always the first thing on the command line, the first argument to your.
To the best of my knowledge, file name is not a reserved word. Oh, I'm sorry. In my command line arguments.
Your command line back there behind this, the layer. Yeah. So how does it know that the first argument to the .py file is going to be file name? Like, you know, in Unix, you use $1.
Yeah, that's actually in my wrapper. So this do demo file that I have here.
Oh, you have two things going on. I see.
Yeah. This one is the wrapper that, like, so this is the code we're refactoring, and this is the consumer of that code. And so that's where
sysargv, that's how it gets it. Okay.
Yeah.
Can Python scripts have flags like -y, -n?
Yeah, there's and parsing all of those is there's more than one way to do it, but I'm really happy with argparse, which is I think now part of the core language. For my needs, it's always been enough. But yeah, there's lots of ways to do all that parameter handling. For this program, I just wanted a way to quickly deviate between them, so I just look at sysargv1. I'm not doing anything robust here.
Right.
Okay. But thanks. yeah, if you want to do argument parsing, there are lots of modules for it, and I would start with argparse, and then if you have problems with that, then maybe look at others too, and other people might have different opinions. So please don't take my answer as anything other than just my opinion.
Great, thank you.
You're welcome. I want to show a handy trick here. This is declarative. I'm sorry, this is imperative. I would like to make it declarative. If you think about it, I'm returning an iterable. That should already start raising some keyword flags in your mind. And that iterable is built based on some pretty simple looping logic. So I would love, if I could, to turn this into a generator or a comprehension of some kind. But what do we have going on? Well, we're iterating over extensions. So that's one level of iteration. And for each extension, we're adding 0 or more items to our output. Which really means there's 2 levels of for loop in here. It's just not obvious. So I'm going to make that explicit first, and then show how to turn this into a comprehension. Once everything that's going on is totally explicit, there's a really handy trick for turning this into a comprehension that's that I don't think many people are familiar with. So stage in, just for extension pipeline stage. Okay, so I'm instead of appending a tuple to a tuple, I'm actually taking the tuple that I receive here and breaking it into its component pieces and appending each of those individually to this pipeline object, and then I'm returning pipeline. But now that I have that, so let's just run it, make show that that works. Pipeline reference before assignment.
This and an E.
Oh, there we go. Yes, thank you. Pipline. Okay, so what I really want to do is I want to return some kind of comprehension that emits this. So here's the trick. Move the thing I want to return into the return statement. Take out the colons. And now this doesn't have to extend pipeline. It just needs to emit this value, because what's going to come out of the whole thing is value, 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 value. And because Python requires it this way, I put that up top. Now my indentation's wonky because my formatter is not working correctly, but that is a 2-level comprehension. If you've ever seen those and wondered how the heck do you keep the syntax right, actually write it as for loops and then just take your output, put it to the top, take out your colons. It does the trick. So now we have a comprehension that returns our pipeline in a single statement, in a single expression. Okay, so there's that. Any questions about that? Is that a new trick for anyone? Have I saved anyone time in the future? Okay, cool. The next thing I want to do now is I do want to think about other file types. What happens if I write this with, if I do this with a TSV? Well, right now it's going to say I don't have any knowledge about what a TSV is, right? Before it would have worked because we weren't actually looking at the CSV extension, but now we are. So we need to vary this somehow. What would we vary? We know we're going to have an entry here for handling a TSV. Of course, if we do this, we're going to have the exact same parsing as a CSV, and that's not going to be right if our delimiters are tabs. And if we run it, we'll see that, in fact, what comes out is not what we want. So any ideas about why the output just suddenly jumped to that? And as a reminder, here's our input. Actually, let me put this on the screen and just trust that you can hold in your mind that that this is now tab delimited instead of comma delimited. But suddenly we got back this. Any thoughts on why?
I believe that the delimiter will change with a tab separated value file. So that can be passed as an argument to CSV reader if I'm mistaken. I'm going off memory, so I might have that wrong.
Absolutely, that's definitely one thing. And there's actually, even before we get to that far, there's actually a more fundamental problem, which is that we are treating every element from the file as if it were a row. CSV reader is actually not even getting the whole first row. It's getting a single string, and then it's getting a single string and a single string. If you look at this, right, so it's not getting all of this as one row that's not delimited. It's getting this as 4 separate rows. So does anyone see why?
Is it the split?
Right here, yep. We want to do split lines. It didn't matter with a CSV file, but it does matter for a TSV file. Now, if we do that, we do in fact get back row, 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 row. It's just that each row is not delimited. But that was a bug we found. Well, knowing that that's there, and knowing that I said before this method is doing like 3 different things, that's one of them. Let's break this method up and really think about what it's actually doing. So the first thing it's doing is text to lines. And that is split lines. Okay. And then we just make this one of our stages. That goes here. We need to make that lines to rows. So we'll make this lines. This now just takes content directly. So now this method is only doing 2 things. I'm going to break out the second thing also, and that is, so the 2 things it's doing. One is it's taking its final output and passing that into CSV reader. But the second thing is it's iterating over lines and removing any blank lines. So our file does have blank lines in it, and you can see our output does not have any blank lines when we output over here. So that's the other thing going on in this method. So let's make that explicit as well. Lines to filtered lines.
So you're trying to split this into as many small steps as possible. Is that what's kind of going on?
Right. Yeah. And let me tell you why as soon as I finish doing this. That's going to be CSV reader of content. Make sure this still works. To CSV, text to rows. That's because down here, we are not yet pointing to lines to rows, text to rows. That would be text to rows. What did I do wrong here? I did this differently than the way I've been doing it. Oh, this should be using file to rows directly because I already have that. explicitly laid out. Okay. It's still wrong for TSV. I'm not claiming that that's right yet, but we'll just take this, which is our list of all the things you do in the changing a file into rows. We'll take that whole list and append it here. So in that, now theoretically, okay, it didn't remove our line because we forgot to add that. Lines to filtered lines to our pipeline. And now we have a working program that works with CSV files and explicitly does all the things that need to be done as part of this one single definition of how to parse a file. And the other change I made, those of you who saw me make that change, I'm just turning the output of this. This used to return a tuple. Now it returns a generator. So I just put the list wrapper around it. So when we run it, we should get the output that we're used to, explicitly telling us what the pipeline is. Okay, so here now our pipeline handles CSV right. The only thing left now is to make this explicit. This is actually CSV. And so in this case, what I really want is something like this. Lines CSV to rows. Because now it will take all of the standard stuff that every file is going to do and then append to it the one thing that's unique for comma separated versus any other separated. So once more, we'll just test and make sure that that works. It doesn't because I forgot to put a comma at the end of the tuple that I embedded in here. I'm really good at that bug, so I recognize it immediately when it happens. There we go. Okay. Does that make sense? Essentially have this thing that's constant for all separated values files and then append to it the one thing that's unique for our particular case. If there's no questions on that, I'll do the exact same thing for TSV. We'll write a method that's a variation on this one for TSV lines. And the only difference is we need to call CSV reader slightly differently in the tab. Okay, in theory now, we work with CSV and we work with TSV. No, we don't. Why not? What did I do wrong?
We have to add that TSV call to that part of the pipeline.
It's right. Oh, whoops. I copied and pasted and I didn't change it. There we go. Yeah, so now our pipeline definition does show TSV, and now TSV files and CSV files parsed exactly the same. So I want to just kind of point at this. Remember the object-oriented code. If you wanted to add support for TSV, how would you do that? There'd be quite a bit to refactor. But here, all we did was added one new method and added a line there. Like basically, that was the entire extent of our work. We had to do some refactoring to make that possible. But now that we have this, we could, let's say we want to support pipe separated files, right? Let's do the same thing all over again for pipe separated. And the only thing there is we're going to use a different helper method. Again, same copy paste, except in the pipes case, and I'm just going to keep these in alphabetical order. For that one, the delimiter is a vertical bar. And now we have support for pipe separated also, right? So adding new types of delimiters is really easy. Now you might still look at this and say, well, yeah, but this is like that's a big function call. That's a big function call, not in terms of time complexity, but in terms of what you have to type. So we'll look in a few minutes about how to even make that more simple. But now that everything is explicit, you can actually see we got a PSV, so we're going to do bytes to text. We're going to do text to lines, lines to filtered lines, lines PSV to rows, right? Our pipeline makes it very explicit what's going on. And the building of our pipeline didn't get any more complicated. Like we can handle any extension that we write helpers for. If it's included in this dictionary, it is supported by our code. Again, assuming that the actual data we're getting doesn't have additional logic that has to go on during it or whatever, just in terms of ingesting it and parsing it. So
yeah,
I can, yes.
Naive question, is this decompressing a file and then working on it, or is it doing it in the RAM, or is it doing it directly on a compressed file? Great
question. So it is, when it first loads the file, and that's a caveat I'm going to put about this code. Everything in this code is RAM intensive. If I were really writing this in production, I would have this operate on chunks of files, doing streams of a bit of a file, then a bit more, then a bit more. But right now, it is reading the entire file into RAM. then it is running that entire thing through decoding. Well, first through unzipping, right? In fact, actually, just to make this obvious, I like when my methods are top to bottom in the way that they're likely to be called. So there we go. So first we're going to unzip it if necessary. And that is happening entirely in RAM. So we take the thing in RAM that we have, that's the bytes from the zipped file. We pass that into zip file. We read out the thing we want, read that fully into RAM, right? So we are very RAM intense right now. This would be better if we were doing, like I say, streaming content rather than the full thing all at once.
Right.
But that's more than I wanted to bite off for this demo. So right now everything's just in RAM.
Okay.
And these files are small, so it's not a big deal. But if we get into megabytes or terabytes, like petabytes, all of a sudden that really matters. But I felt it was a little too much for this demo. Okay, so as I look at this now, I think there's a few things I want to talk about right now compared to the object-oriented code we had before, and I can flip back and forth between them at any point if anyone wants me to do a show them both. Or jump back and forth. But the first thing I'm going to say is the code we have here is very, very testable, in the sense that because there's no side effects, I don't have to test for side effects. All I have to do is say, if I pass the right thing, if I pass the thing into this function, do I get the right thing out? And each of these functions does one thing, and it does it well. So do I get the right list of extensions? I can write some test cases that just pass in a file, pass in this file name, this file name, this file name, make sure I get the right extensions out. I mean, this is easy enough. You probably have like 2 unit tests, right? But in a way, that's actually a good thing. As I look at each of these stages, each one is fairly easy to test. If I hand in the bytes from a zipped file, do I get out the contents of the first file in that zip? That's easy to test. I can test that this works. Each of these stages does one thing and it does it well. And many of them, the testing is so obvious that it could possibly be left off, depending on what your rules are around unit testing and how your team works. The second thing is, it's building the pipeline is not the same as executing the pipeline, because the pipeline is just a bunch of functions that have not yet been called, which means testing the pipeline itself is very easy, the pipeline builder. If I give it a file, do I get back the right functions in the right order for doing that file? And so I could hand code a few unit tests that say, if I give you .csv.zip, I should get back this function, then this function, then this function, right? Or I should get back this function, and then everything after that is the same as this other case. Or write your tests however you want to. But essentially, I'm just comparing the functions I get out of the builder, the order of those functions, to a known order for a particular case, and making sure that I'm getting the right stages out. I don't have to execute the pipeline to test it. I don't have to execute. In fact, the only thing I have to do to test the whole thing together is run a single integration test or a couple, where I give it a couple files and just make sure it all works in unison. But if I can test the pipeline is being built the right way and that each of the stages does the right thing, that gives me very, very high confidence that the overall thing is going to work as expected. The second thing is, in a lot of cases, our code is much simpler than it was. This build pipeline is a little complicated if you're not used to that nomenclature, but if you look at it for a minute, squint your eyes right, like it does something that's pretty obvious. And similarly with others, like somebody new coming to the team can work on any of these individually and make meaningful decisions about them. Now, granted, they're very, very simple. One might say they're overly trivial, but the benefit you get from that is this testability and this composability. And some of these methods I would probably make available to the outside world. In fact, content split lines is already available to the outside world. Really, what I'm saying here is I'm using content split lines to solve this problem, which happens to be the same as stir split lines if I pass in content, which happens to be the same as, let's just make that explicit, what we're calling text to lines is stir split lines. Right? Now I've reduced this in function down to a single definition that says this thing that I'm verbally calling text to lines, because it's easier for us to follow in here, is just the same as the built-in split lines function of stir. And we're going to find that a lot of these actually can be reduced to a single line like this. Whether any of them individually should be is a good question, but in terms of just decomposing our code all the way down to a purely functional way, we can go quite a ways. and make our code actually very small. It becomes a little harder to follow if you're not used to it. But that option is there. So I'm just going to leave this one for the moment and just show that that does in fact work. Still parses files just fine. Oh, and by the way, because we added TSV and CSV, because our pipeline doesn't care about compression as it relates to the contents, it just knows how to decompress. We got zips on TSV and on CSV for free, on PSV for free, because we already have a method that unzips. Like, since it's all it does, it's going to work for any zip file. So we supported 4 extra combinations of extensions simply by adding, a couple little methods and a couple of rows here. So that kind of extensibility and composability makes a very strong argument for the functional approach to things. Quick time check. This at this point, I would say, is pretty good. There's a couple things I could do to make it better. But in terms of like the overall refactoring process, we now have the same code we had before with 2 new extensions supported. Does that feel comfortable to people so far? Because now's where, for those who can stay longer, now's where I start running your head through some really funky stuff you probably haven't seen, or maybe you haven't seen, but that gives some really interesting approaches. So any questions on any of that so far? Cool. Okay, so the next thing I want to do is I want to add support, and I'm just going to do this with a copy paste because I can't remember it off the top of my head. I want to add support for tar files as well. So TGZ as an extension. So I've got an import here. Just like I import zip file, I also need to import tar file. And the only thing I need is the open. So I'm going to call that tar open. And I need a method that implements it, which happens to be about the same size as the one that does zip. So we'll throw that down here, bytes zip to bytes. We'll throw bytes TGZ to bytes as well. You'll see that the method is very similar to the zip one. How tar files work and how their API on the module works is a little bit different, but the basic idea is open up the tar file, read the contents in, extract the item that lives at file name 0, read it into memory and return it, right? So it's essentially the same as the zip implementation. Just for a different wrapper. With that in mind, we can then just literally do this. This is now TGZ, and that's bytes TGZ. Now we have support for TGZ files as well. It was that easy. Additionally, because our pipeline doesn't care about there being a specific number of extensions, we're assuming all extensions are meaningful. If we have a TGZ, not TGZ, TSV, and we happen then to zip it, it still works. But let's say we have that zip and we TGZ it. That's not the one, is it? It is, oh, the other way around. The TGZ, and then we decide to zip that for some reason. It still works. So now we are decoding zip to bytes. And then the next part is now those bytes are a TGZ file. So we decompress it. And then we just go into the rest of our pipeline. So we now have extension chains that can happen in the real world that we just handle normally. Like, we don't have any special cases to like think about what if the number of extensions changes. It is it's predicated on the assumption that all extensions matter. And the logical, like business assumption that you're not going to try and cram a CSV file into a TSV wrapper. That would break this. But in terms of like compression and having different kinds of compression wrappers, any wrapper around the content that we support, we can daisy chain them together as much as we want. So we get that for free by having a pipeline that builds dynamically. So just one nice little bonus. And so you saw that adding support for TGZ was literally those 3 lines of code, and we were done, right? And this is where functional paradigms are often very appealing, because you can, with object-oriented, you're consolidating behaviors into related objects, and in functional, you're decomposing everything and saying, well, what's really going on is I have this chain of operations, right? Take this and transform it this way, this way, this way, this way, give me the result. And so this becomes very extendable in certain problems where object-oriented gets more and more complicated, this becomes easier and easier. Now, there are cases where the reverse is true. I'm not saying functional is the mecca, right? But in general, we can look at these things and make a lot of sense about what's going on and understand each of these pieces individually, and then we just see them get built and work with them. So that's a lot of the motivation of why functional programming. Okay, so now I'm gonna get into the fun stuff. This stuff is all extra credit. Everything up to here has been our basic program worked. We made some modifications to functionalize it. We've made most of our functions, all of our functions are quote unquote pure. Most of our functions are additionally one-liners, very testable, very easy to understand. And if there's more than one line, it's just because it's, the complexity of decoding things. Now what I want to do is I want to reduce all these functions to what they really are at the most core component level, like I did here. So I will caution, everything after this point is probably anti-Pythonic. We're going to decompose too far, but I just want to show what it looks like so you kind of know what that's like. If you were doing this professionally, I would say I would probably stop at this point, assuming our starting code was really where we were starting and the problem really wasn't this simple. This is probably where I would end up. One other note, somebody mentioned before that we have a lot of, we've turned all of these into really simple one-liners. And the reason for that is for testability, right? Yes, this would be more performant if we consolidated some of these, if we took out some of the function calls and consolidated things. But what we're really talking about is you spend far more time reading your code than you spend writing it. And when you have to fix a bug in a hurry, having your code very explicit and very well-defined, very declarative, makes it easier to find and fix bugs. So we're giving up a little bit of performance in exchange for readability and maintainability.
Does this IDE have some kind of versioning thing where you don't have to do file save as?
Well, so I'm not doing, I'm not doing save as.
Could you do like a snapshot?
I can give everybody a snapshot afterwards. If you want to see it in this state, I'm happy to.
I'm just curious.
Yeah, I mean, I can just copy it right now in the state it's in. And I'm happy to send that out if you're interested. I don't, it's funny. I know my way around my editor for the things I do, and that's one that I don't know. I just never do it. Okay, so how would we decompose this more? Well, similar to what we did here, this is really just, it's just naming a call to this. Oh, and the other reason why I would still leave this here, if all we're doing is stir split lines, we could actually copy and paste that right there. But I like the idea of it having name, because when I'm testing my pipeline, I can test for the name text to lines rather than testing for stir split lines. Like I can just test for the names that I'm expecting to see. It's in performance wise, it's not going to be any faster or any slower. It's going to be about the same. Well, exactly the same. Actually, not quite. This one might have one extra instruction it has to run. But it's going to perform the same, but it just makes very readable. My pipeline over here reads very cleanly. Right. Some of the things we're about to do will take away that readability, which is why I'm going to say they're anti-Pythonic, but I'm going to do that same thing. So lines to CSV rows takes content and passes that on as the first parameter to CSV reader. Well, that means lines to CSV rows is just CSV reader, right? Does it still work with CSV? It does. Okay, so simplified a little bit. And lines to PSV rows is actually exactly the same. It is also just CSV reader, but we have to add that extra parameter. And this is where things like func tools come in handy. So if you're not familiar with func tools, I would encourage you go read about it. But we actually care about a particular thing called partial. We're going to make, we are going to make a function call that will be a wrapper around another function call where all that varies is a single parameter. And to do that, we say we are, this lines PSV to rows is a partial function. The function that it wraps is CSV reader, and it adds delimiter. This is now a function. Partial is a function that returns a function. So this is a wrapper function. I'm not going to dive on why it works or how it works, other than to say it's a way to say, I know I'm going to call this function and I'm always going to call it with these parameters. So please give me a shorthand notation for that. So it's a shorthand notation for calling. It will still take content and that comes into this. The first parameter that's passed to this becomes the first parameter to this. So CSV reader is going to be given content first, and then whatever keyword args we have. If we had arguments here, like 1, 2, 3, our content argument would come after the positional arguments. So we'd call CSV reader with 1, 2, 3, and then content. So be very careful about parameter ordering and make sure you figure out how partial works to get the right parameters in the right place. But I contend that this is actually really explicit, right? Line CSV to rows, just call CSV reader. PSV to rows, call CSV reader, but add this extra parameter. Let me just throw this import up here. And TSV rows, well, that's going to be the same thing. TSV rows is the same thing, except our delimiter is just the tab. Okay, so now instead of writing functions, I'm actually just wrapping existing functions with slight variance on their behavior. I contend that if you're used to reading it, this is much easier to read because everything's together, so you can just glance at it and see, oh, this is what's varying. Got it, right? This totally makes sense. Some people will have a hard time reading that. So it depends on the team. If we do that now, we're still decoding all of our files, right? Everything's just working fine. It doesn't care. The one thing that changed though is when we print out the pipeline, it is now suddenly telling us that we're calling this functools partial thing rather than giving us the name of the function. Similarly up here, it is actually calling method splitline of stir. So our output became harder to follow. If we want to test, we can test against these names. So for unit testing, it's still easy. Did our pipeline put this method, then this method, then this method? It's just a quality checks. But in terms of like output, you have to kind of jump through hoops to make the output readable if you're going to start decomposing this far. So just caveat. I would contend we can actually do the same thing for this. Instead of writing this as a generator, what if we wrote this as a filter of content and whoops, hopefully it's a function first. Well, I'm just gonna, if X is truthy, include it in the output, right? Okay, so we're taking the filter function, which is a function that takes as its input a function, which is our operator on every element in the list, and the thing that we're iterating. This function is applied, and if it returns something truthy, the item is included in the output, and if it returns something falsy, the item is not included in the output.
I think you can just use none for that. There's a special case for it.
Really?
Not
like
that
this?
it really matters. It's not really a big refactor.
Like that?
Yeah, I think you can just do that.
Interesting. Well, let's test it and see. That worked. Okay, nice. Thank you. Actually, let's test it with a file that has a gap in it. Yep, that worked. That's handy. Okay, well, in that case, I'm going to put the Lambda back just to talk about this. Our test is the element truthy, is the element falsy? If our test was, does the row start with a hash mark? Like whatever our test is, we just write the test as a Lambda expression. If you don't know Lambda expressions, you can write a function and then just pass the name of the function right here. It'll do the same thing. And thank you, the unit Lambda for filter. I like it. I wish I'd known that a long time ago. Now that we have this into a function call that takes this parameter and then our parameter, that actually looks like another case where we can reduce this to a partial. Filter is the first thing. None, our Lambda, is the second thing. And we don't need to express the third thing because it is already implicit because it takes whatever's passed to this and appends that to the end of this list. And it happens to be that our ordering is right, so we don't have to jump through any hoops to get none in the right place. It's already in the right place. So now we have a partial for that. That's kind of cool. And look, lo and behold, this one's kind of the same. This one's a little bit different. If we wanted to call this one, now we have to do, we can call, so content decode, content is bytes coming into this. So this is bytes decode content, and it happens to be that there is a name for this parameter, and of course I forgot it off the top of my head. If anyone remembers, tell me, otherwise I'll go look it up. It is
Encoding.
Oh yes, thank you, encoding. Encoding equals UTF-8. So if we run this, it still works, great. Now let's turn this into a partial. Similar, functionals dot, whoops, not functionals, partial. Remember how you imported. Ah, boy, this is just embarrassing. Bytes decode. We're going to pass the encoding. We don't need to pass content again because it's going to get passed, and because it's positional and the only thing we have here is keyword, it'll go to the right place. Put this extra line back and test our program, and lo and behold, it still works. Great. So now our program almost fits in one page. We have a couple functions that are a little bit long-ish, but not too bad. I would at this point personally probably just move this right up to here. I would take the, this is testable, but what we're doing is so blindingly simple. I might actually just put this right up in here. That would make this a little bit shorter. But in terms of reading what this does, this is now a very, very different program. But because you saw how we got to it, it should be obvious how each of the pieces works. And more importantly, if you had to go back and look at this in a few months, you should be able to pretty quickly figure out, the pipeline might take you a few minutes to reorient on, but the individual functions that make up that pipeline, every one of them should be very easy to reason about and figure out. Many of these functions would be moved back out into some utility module because some of these things are going to be useful in the same way for different purposes. So you might refactor these out of this module. But the basic structure of this module now is actually quite straightforward, very condensed, in some ways non-Pythonic, but also elegant in my opinion, and very easy to track what's really going on. So that's my crash course in refactoring functional, object-oriented into functional with a fairly simple starting application. And I'm happy to answer questions or further explore any of these pieces. Oh, whoops, we talked about making this a reduction. Would anyone like to see that? Turning this right here into a single function call, single one-liner.
Sure.
Okay, great. Who knows reduce? Like most people are pretty familiar with map, and I think most people are generally familiar with filter, but I don't know a lot of people who understand reduce well. So does anyone have questions about reduce? What it is, what it does? What am I talking about? No questions. Okay, well, I'll assume everybody knows reduce then. So I will just do a reduction. So we're going to do reduce. Our function for the reduction is, this is what do we do with each thing? So we take x and y, where x, I always get these backwards. The first thing we're going to get is the accumulator. And the second thing we're going to get is the thing we're iterating over. And we're going to iterate over the pipeline. So these are going to be stages. The accumulator is actually content. We're going to rename it just because we don't want to override the name of this variable. But given a block of content and a stage, what we want to do is return the stage applied to the block of content. And our sequence of things that we're iterating over is the pipeline. So it's this. And our starting value is the initial value of content right there. Let me just make this multiple lines so it's a little more readable. And boy, I would be happy if I weren't having these linter problems and my auto formatting was working on save. Okay, content, all that is fin read. So let's just move that there directly. Now we don't need this content variable at all. Well, actually we do. I'm gonna say reduce We no longer need to do this because we've already done that in our reduction. And because all we're going to do is yield from this, I would say let's just move this to the yield from directly. There you go. So we now have a reduction that starts with the original file contents and then iterates over the stages. And for each stage, it applies that stage to the pipe to the content, and that then becomes the in value for the next time through. So you can see now that it's the same process. We're still building up this thing, but we've gotten rid of all the explicit mention of intermediate values. Those values still exist. When this does the iteration, it still is going to have the same random implications. But for some cases, this may be a lot easier to read because we've gotten rid of content. We can actually go ahead and rename this nicely.
So you just talked about RAM a little bit. So maybe you already addressed this and I missed it. But right now, this function, like you're doing all these yields and nested iterators, but you're still just reading in the entire contents of the file to begin with. Like, why not just pass in fin and just iterate over, fin.readlines or something? Is that just because we want to be able to control what lines we're reading or how we're splitting the lines? Do you get what I'm saying? Like you can just iterate over the file line by line by just using treating file as an iterator, right? But right now you're loading the entire file into memory and then running the processor over it.
Jeff, you're...
There we go.
Yeah.
I had to unplug and replug in my mic. It failed on me. Sorry about that. Okay, so I did address that a little bit earlier. The primary reason is these two functions right here are quite a bit more difficult when you're streaming data than when you hand them the entire contents at once. So for purposes of making the demo easy, I wanted to keep these easy, which meant reading the file as a single shot. In practice, I would actually read, I would open fin, and that would be the first thing passed in. And my first function would basically start reading that file in chunks and yielding one chunk each read. Because yeah, and that was something I did mention before. This will be very memory hungry if your file is big. Our files happen to be 100 bytes each. It's trivial. But if you get to megabytes, and especially to gigabytes and beyond, you definitely want to turn this into a stream pipeline rather than a values pipeline.
It just seems like when you're talking about functional stuff, you probably want to be working with streams most of the time. So.
Yeah, and that was a choice for this demo just to keep it simpler.
Sure.
Because the streams, if we weren't doing the compression, streams would actually be equally easy. But that decompression stage, boy, the first time I had to figure out how to do a zip on the fly, that was exciting.
And then another small comment, which is like another really minor refactor, is in reading from the zip file. If you go down to that function.
Yep.
Right now you're doing like with open.
Yep.
You don't have to do that. You can just do archive.read. I think it's
really? Okay.
And you pass
so in
the
theory,
file name and it just returns you the bytes.
Archive.read, archive, something like that.
You don't have to do RB or as fin anymore.
I'm sorry, say it again.
I don't think you have to do RB.
Sorry, you got really quiet. I couldn't make out the last thing you said.
I don't think you have to do RB either, the mode.
Okay.
But
well,
I'm not sure about that one.
Try that, see what happens. And zip. Yep, they liked it. Cool, thank you.
Yeah.
Nice.
So, can I keep asking questions?
Please, please. This is as much for me as it is for everybody else.
So, I guess like the benefit of this is having, like, you just define more pipelines, right, down at the bottom.
Right. So one benefit is it's very, very extensible.
Right.
And actually, if you were to think about this same thing in an object-oriented way, as soon as you start adding more, for example, more decompression methods, you're really talking about one class per decompression method, or like the true object-oriented way to do this would be start figuring out what's the one thing this class does and the one thing this class does. And you end up getting classes everywhere. And so part of the motivation here is to say, well, if all the class is doing is providing a helper method, just write the method, right?
Yeah.
Take away the bulk.
So I don't remember exactly the class that we started with, but the way I would have approached this would have been like not making it purely functional,
Mm-hmm.
but like we've identified all these different parts to the pipeline now, right?
Mm-hmm.
And so each of those parts is really a method on a class, right? And then you
Sure.
might want to add a new parser, but all it does is change spaces or it separates on tabs instead of commas, right? So you
Mm-hmm.
just override that specific method.
Absolutely, and you could definitely do that here. Every class we wrote, I'm sorry, every method we wrote could be a class method.
Yeah.
And so I would have a few questions about that. The first is, does the class add value? And if the only value you can think is people are used to instantiating a class, instantiating an object and then operating it, if that's the value it adds, then maybe you have a wrapper object around this that does that. But if the class has any state that matters, then you have to think about how do you move that state through your pipeline. In our case, we were able to identify that the only state the class had was involved in setup, and we could just basically extract that out.
Yeah, I'm not too concerned with the state. I'm more like thinking of like, I guess it's not as big an issue now if we started using typing everywhere, because that would define our interface, but you would use a class to define your interface. So then you would just tell somebody, hey, you want to add a new pipeline, then just subclass this thing and override what you need, right? Like I've already given you the entire structure, so you don't need to know all the little details. You just need to know, oh, I need to change this part.
True.
Right.
Or what I could suggest also would be that this would be the default stages for extension, but any consumer would actually pass in the stages object they want to use and default to this one. Assume that this is how we're going to handle all these, but if they want to make a copy of this and vary one of these and provide their own function to be the helper, as long as this method also then takes the default stages, or takes the stages lookup, whatever we want to call it. If they pass something in, we use it. If they don't, we use ours. Then that gives them the ability to get that same kind of overriding. They can just add something to the pipeline. Now, it's a little more complicated. Certainly, extending the class is very easy.
Yeah, because like if they wanted to extend it this way, they would have to know the entire pipeline or like the special file to rows like shortcut, you know,
right?
As opposed to just knowing like, hey, if I subclass this thing, everything is already implemented except for the one part that I want to change. I don't know. I'm not like objecting to this. I think it's like really
right. No, and those are great questions. And I would say that the best answer is it's going to depend on context, right? There isn't a right answer. I think that in general, people rely on classes to provide things that end up making code more complicated in the long run than it needs to be. But they get there, like the road to, what is it? The road to Hades is paved with the best intentions, right? I think a lot of object-oriented code starts with the right intentions, but ends up, you get so many levels of extend this to do this and extend this, you end up having to learn all those same things. What's the actual thing I need to vary? What do I write in my class to vary it? And if the documentation shows, if you want to add a new compressor, here's how, that's great. But in practice, I find myself kind of having to jump through hoops, even with extending classes, to understand how it's supposed to be extended properly. So I don't know that it adds as much value as some people believe it does, but I think that's a very open to discussion statement. I don't claim it's right.
Yeah. Well, I mean, I'm pretty biased just because
sure,
class and click all work that way, like where you just pass in or you override different parts of a class.
Yeah.
But the other thing I was going to bring up was like, in terms of not being purely functional, but having some hybrid approach is like, and I'm also like, I agree with you that like, hey, like even the Flask and like click classes, there's so many things to override at this point that you do end up having to dig into a lot if you want to know what's going on. But one of the other things that I'm trying to push more and more as we like refactor is like composition. So we're still using classes, but we're not necessarily saying override all the methods. We're saying like it's composed of a bunch of different like workers, which I guess it has the other problem of now I've like made a bunch of different classes that I have to understand. But
Yeah, but the way you would do that in functional terms is instead of either passing in the emitter or deriving in some way what pieces compose your final object. Instead of that, you would be passing in functions as parameters to the function you're calling, right? So instead of passing in some class or some value that turns into an instantiation of a class in a factory somewhere, you would literally just pass in the helper functions you want. And so it's up to the person writing this to say, here's the things you can override, and you override it by passing in a different stages lookup table or passing in a different, whatever. In our case, we're not making those explicit or even implicit. You can't do that with this code yet, but that would be a direction I would write. This method would become a little more complicated. Actually, there would be a wrapper method. That would be a little bit complicated. That's where all those variations would be expressed. And then this would be what gets called once it's figured all that out. And so that the build pipeline method ends up building the correct pipeline based on what the user passed in or whatever, right? So again, not saying my answer is the right answer as much as it really does depend on context and what your users are used to, right? If you take an API that's been object-oriented for years and suddenly make it functional, that's going to throw your users through a loop too. So
yeah, I was just thinking about like what would Flask look like, or just like a web framework in general, if it was entirely like pipeline composed. Because like when it comes down to it, Flask and Click, which are the two like frameworks where you're basically like taking some form of input and producing some form of output.
Yeah.
Like they really are, like the classes are just encoding a pipeline, but just as methods instead. And so you could theoretically extract that all into some like functional pipeline instead. I'm wondering how, I'm not wondering because I want to like say this method, this pattern is good or bad, but just like I'm wondering like what that would even look like.
Yeah, and I think probably my gut feeling on that is probably first you would pick one piece of the code that just happens to be really thorny and hard to work with and turn that into a functional approach, but leave your API that users use still class-based. And over time, just start making more and more of it, right? Because the advantage you're going with for the functional code is more than anything else, readability and testability. I can think very clearly about how to test this, but if I'm testing methods on objects, I have to think about all the ways they can vary. That becomes more complicated. So that's good for integration testing, but bad for unit testing. And so if you just find the pieces that can be extracted out like this, take any function that's already basically pure and officially make it a pure function, that makes that piece more testable and maintainable. And over time, you'll find the right balance of these parts should be classes still, and these parts don't have to be. So let's go ahead and get the maintainability improvements or readability or whatever they are, or not,
Right.
Depending on the individual case.
One thing we're doing in Werkzeug is there's a form, like a multi-part parser for form data. And there's this kind of concept that's gotten a lot more popular since ASGI came out, like async, called sans.io, where your parser doesn't rely on having like reading and writing directly from streams. So you just pass in data to this like event parser. So it's not quite the same sort of functional because it does like, the whole point is it's a state machine now. But it's a very similar idea where like, instead of writing one big function or like set of methods, you have some like pipeline where you're mostly just passing data through it and like passing more data into it. So yeah, like we're kind of moving that way in certain places. Not quite the same as this because we have state still, but
yeah. And the fun part is like the balance, where the balance comes out is going to be different for every team, different for every project, different for everything. But the basic idea, when you start seeing the gains that you get, you start finding yourself, and this is the path I've followed, but I've heard similar stories from a lot of people. Once you start moving towards more functional approaches, you find that more and more of your code actually is a really natural fit for functional, and that if you're test centric like I am, that writing all the tests becomes a lot easier. So just that benefit alone has caused my programming to be more and more functional over time. it started with, of all things, learning React. And once I saw the difference between declarative programming versus imperative programming, and functional is basically like the embodiment of the best of declarative as opposed to imperative. And once you start seeing that, you just sort of find that some of the notions are really, really helpful, some of them not so much, but you'll find like a middle ground that's good for you. And I've tended to find that a lot of people find roughly the same middle ground in the Python world, because the Pythonic way of doing things is good already, and just approaching it from a less object-oriented and more functional approach gives you code that is better in some ways, worse than others, but that does have very clear benefits.
Mm-hmm.
I like that Pythonic.
I will suggest to you and anybody else who's interested in practicing this sort of stuff, Advent of Code, which is the 25 code challenges in December, lends itself really well to this style of programming. I think I did a lot of this in last year's solutions, just because I kept wanting to like factor out behaviors that were common.
Mm-hmm.
So you ended up with like, because you always start with some input file and like do some sort of line by line processing on it or something like that. And so it's a really good way to, it's a really good excuse to write this kind of code if you don't have like your own project for it.
Yeah.
Hey, Jeffrey, is this a real world script or an exercise?
I'll be honest, it started from a real world problem, which is why I know how weird it is to try and decompress zips on the fly. I was writing a project where a snapshot of the database was taken every day. The client did not have access to the database to query it directly, but they did have access to a CSV snapshot once a day. So iterate over a multi-million row CSV and find the differences from yesterday to today. Figure out where the upserts are and where the deletions are. And I ended up basically having to do all of this, like figure out, okay, let's do this transformation, now let's do this transformation. And this is all on byte streams. So it's chunks of bytes coming through at a time, decompressor releases, here's the next 12 bytes. Oh, here's 106 bytes. Okay, here's 2 more bytes. And so you get these really weird like stages. But the actual flow of the code was very, very simple. Once I got it down to each stage being a single thing, it actually became very easy to look at the pipeline and say, okay, yep, this is the pipeline, and the data goes in this end and it comes out this end decompressed and parsed, and in the right group, whether it's an upsert or a deletion, it just comes out right. So that was the motivation for taking this notion where you have 2 or 3 things going on at once and turning it into this example, which is overly trivial, but based on, like I say, that real world instance.
I wonder if this was an interactive script, you could have it warn